Hello class, I would like to introduce some comments about this lecture which is related to chapter number 1, which is the first chapter of this course about science and sustainability. Probably you have reviewed this lecture already. This document is very long and I'm going to go through all the details. I just want to make comments in some of the slides that probably are not totally documented in your textbook because those slides were included from material that I have. Okay, in this slide you can see the objectives of this chapter. Okay, there is a list of them. But one of the two items that I want to make a little bit of more emphasis are this one about ecological footprint and how the population grow and the consumption of all the resources that we have in the planet are defining a very critical point in the sustainability of the planet today, which is basically one of the most important concepts behind environmental science. I'm going to skip some of the slides and I'm going to go through those ones in which there are not too much documentation in your textbook. For instance, this one about the evolution of the Earth. Why I include this slide here? Because I strongly believe that we need to have a framework of how was the evolution of the Earth in order to understand what are the resources that we have, but besides that, how the cycle of the temperature during the evolution of the planet has been taking place and how that cycle of the temperature looks like. Because that is a point of discussion today. Everybody is aware that we are discussing about the global warming. We are discussing about the over greenhouse effect. So I would like to give you some scientific framework of how the temperature has evolved during all these years, from the starting point of creation of the Earth to the current days. What you see here in this big spiral, okay, is the evolution time of the planet. Starting here 4.5 billion of years ago, all the way up to the current days. And the scale that we are using here is a geological time measured in millions of years. So, just to tell you, if we are talking about 100 years, 100 years in geological time was yesterday. Okay, so keep in mind that the evolution of the Earth has been taking place in 4.5 billion of years. Actually, our galaxy, okay, the Milky Way galaxy is calculated to be about 14 billion of years. And our big star, which is not the biggest one in our galaxy, which is the Sun, very important for us, okay, is around the same age of the Earth, 4.7, 4.9 billions of years. That is the estimation. Okay, but in any case, what you are looking here in this spiral are geological time that is split in different eras. Precambrian, which is probably one of the oldest, and that was just the period of time in which the atmosphere in the Earth was under development. The atmosphere at the very beginning or in the youngest days of the planet, of our planets, was very thin, and today is calculated to be at about 500 kilometer thickness. Okay? And of course that atmosphere is split in several layers, and every particular layer of the atmosphere have a particular role. But I'm not going to detail that in here. That is something that we're going to discuss in other chapters as we are going to progress in this course. But the most important thing is that in this era, most of the organisms that were there in the planet were organisms that really, the complexity of them was very simple. Actually, most of the life over there, they didn't have any skeleton at that time. Until probably 500 millions of years ago, in which the first vertebrates, animals, start to develop and show up in the planet. And that is very important because it's for those guys, okay, in which the planet start to produce the resources that at some moments creates the reservoir of fossil energy that we have today, which is under discussion how to handle or management that energy that is a fossil or is coming from a fossil origin. So, well, as you can see here, during the Cambrian, 500 million years ago, start to develop all the vertebrates. So, if we are coming in here, okay, then we are getting into the Paleozoic era, okay, and around here, very close to the Permian, 250 million years ago, okay, well, the planet was able to see one of the major extinctions in the Earth. And that is very important for environmental science because that extinction was created, as you're going to see in some slide that I'm going to show you just in a few minutes, was created by a over greenhouse effect, in which the temperature over the surface has been one of the major or the greatest ones recorded in the Earth. Okay, so that took place in the Permian 250 million years ago, when, as I mentioned in the introductory of this class, all the continents were attached together in just one big continent that was called Pangaea. But the important part in here is that in that extinction, almost 95% of the marine life was removed from the Earth. And most of those guys that were wiped out from the Earth, they start to create the fossil energy that we have today. So you can see that most of those resources has been taking more of 250 millions of years to be created, evolve, and deposit in the subsoil of our planet. Okay, so has been a very long period of time in order to have those reservoirs of hydrocarbons that we have today. And that's why, first of all, it's very valuable, but also we need to take care of them, because if we consume all the hydrocarbons at the rate that we are doing today, most likely that those ones are not going to be present or are not going to last for a long period of time in our planet. And the real thing is that we still need the hydrocarbons to sustain our life. But the most important comment about this is that we need to make a very wise use of the hydrocarbons. And this is an idea that I want to introduce from the very beginning of this course. Okay, so if we move forward in here, getting into the Mesozoic era, Jurassic period, about 200 million years ago, okay, we're going to end up into the Cretaceous, okay, between 150 million years ago and 60 million years ago. And at the end of the Cretaceous, going forward into the Tertiary era, there was another very big extinction in the Earth. At that moment, that extinction was created by an external factor. A meteor hit into the Earth and create what we know today as the peninsula of Yucatan in Mexico. But that create a big crater, and that create also a very large disruption of the climate at that time. And many of the big animals or creatures that we have in those days, they disappear because of the high concentration that was created by this impact of sulfur in the atmosphere. And the victims, or the guys who were really affected by this disruption in the climate produced by high concentration of sulfur acid in the atmosphere, or gases in the atmosphere, were the dinosaurs, as everybody knows. Probably in some other chapter, I'm going to detail a little bit more why, or what is the theory behind the death, or the massive death in those days, of the dinosaur. But for sure that this, in this time, was one of the biggest periods of extinction. So the amount of dinosaurs that dies at that time, all that organic material was deposited in the subsoil of the earth, and they contribute in addition to the creation of hydrocarbons, again, fossil energy resources. So it is not good to say, but because of those extinction, today we have a lot of fossil energy and resources in the air. So how many extinctions we have seen in the air during all this geological evolution of the planet? Well, we have 5. As you can see here, whenever you see this E and E and E, those are extinctions events in the planet. Okay? Now, the most important thing is to check how was the land or surface temperature during those periods, because that is very important in terms of the greenhouse effect that we have in our atmosphere. Okay? So the human beings, they start to show up in the planet about 1.8 million years ago. And there was a very good interaction between animals and men about 10,000 years ago. In other words, in geological time, before yesterday. Okay? Now, if what we are showing in here, this extinction, that is a warning mark. This era now, or that period, is not the tertiary, is the quaternary, is today. So, there are many people who believe that if we are continue in the same rate of consumption of our energy and resources, probably we might face another massive extinctions in the earth in the future. And what is the meaning of the future? Well, probably is a period of time that you and myself, we are not going to be able to see. But our future generation, perhaps, they're going to face that time. But we are on time. We can reverse that time of prediction, or that kinds of prediction. Okay, so going back to the temperature of the Earth, well, we have here, in this slide, we are in the Precambrian, 550 millions of years ago. I mean, in here, when the first vertebrates start to show in the planet, okay, all the way until today. So in here, as I mark with this arrow, this is 250 million years ago, okay, and this was one of the massive extinction in the Earth, in which 95% of the marine life was wiped out from the Earth. What we have here in the vertical, so this is geological time from the Precambrian to the current days, and what we have here in the vertical is temperature measured in Celsius degrees. For those of you that are not really accustomed to the Celsius degrees, this lower value here of 10 probably is about 40, no, more than 40, between 40 and 50 Fahrenheit degrees, and 28 to 30 degrees around between 85 to 95 Fahrenheit degrees. And in here you have different stripes of colors. You can see here ice house. I mean, the lower part of the atmosphere, which is the troposphere, in which we have the major density of concentration of oxygen, okay, was cold. In here was in a process of cooling, And here we start to develop of what is called a greenhouse effect. The greenhouse effect is something that is given by the mother nature in our planet. Is not a bad process. Actually, it's very good, because the greenhouse effect prevents the planet to be in a continuous freezing condition, and that allows to sustain the life that we have in the earth. Okay, so that's why you see this kind of cyclical behavior of the temperature. That's what is many people call ad hoc behavior, and that is true. We need to accept from the scientific point of view that the variation of the temperature during the evolution or geological evolution of the earth has a cyclical behavior, is a host, and that is correct. Now, nobody have that into discussion. The point is the extreme values of the temperature within this cycle. That is the point of concern. And most of the concern has to do when we have a extreme greenhouse effect in the atmosphere. In other words, a very high temperature because of the concentration of the high concentration of greenhouse gases within the troposphere, which is the lower layer of the atmosphere. Okay? So, for instance, when we face that extinction 250 million years ago, well, has been recorded today, and we know, and that is true, that we got at that time an extremely greenhouse effect. So it was very high warming situation in the planet, and that excessive warming in the planet was responsible to create that massive extinction. Okay? Because of the high concentration of greenhouse gases during that period of time. What happened? That is the question that we are going to try to access in the next coming slide. Okay? So one of the theory explain that 250 million years ago, as I mentioned, was just a big continent. That continent is called Pangaea. Well, actually this research is coming from the environmental school from Stanford University, and was done by the Dr. Jonathan Payne, okay, in which he sustained or he claimed that it was a great volcanic activity that expelled a lot of CO2 to the atmosphere at that time. And the level of CO2 in the troposphere was extremely high, that create very high temperatures in the planet. And that was the responsible of trigger the big extinction of all the marine life at that time, because the first layers of water in the ocean were very warm at that time. Okay, this curve that you see here, okay, is giving to you an idea of the percentage of extinction. So in this part and in this part, in these poles of the continent, the extinction was very high. That black curve is the prediction of the model that was introduced by Dr. Payne from Stanford University. And those green dots that you see over here is the matching with the actual fossil information of data that we have today. This graph over here is showing you in a very hot colors, reds, the temperature at different latitudes of the planet. It was very high in here and also in here, as you can see these very red colors, okay, that match this graph that you have over here. And just next to the right, we have this temperature in the vertical, and this is years between 250 million years ago and then 249 million years ago, around 3 million of years during the Permian. And you can see how the temperature rise very hard during that period of time because the high concentration of greenhouse gases in the troposphere. In here you have the graph, and in here in this graph, in the vertical you have percentage of seafloor anoxia. What is the anoxia? The anoxia is the lack of oxygen in the seafloor. So the percentage of lack of oxygen or anoxia during those period of time, during those 3 million of years in the Permian, was very high. That explains how this greenhouse effect in the planet produced this massive extinction. But one of the besides point within this information is that when we start observing a dramatic increase of the accumulations of greenhouse gases as CO2, there are some others, methane and so other, okay, water vapor as well, but at least this one that is very important, as we increase the density of those gases in the troposphere, the temperature in the surface land, in the surface and in the ocean are going to increase dramatically as well. And that is going to create a disruption, not only in the climate, but also in the sustainability of the resources that we have today. That's why these two slides are very important, guys. Okay, so that is one comment that I want to make in here. I'm going to leave to you the reading of the rest of the material that you can find in your textbook. Of course, you are welcome to consult with me if you have any doubt. Okay, some other thing that I want to comment in here is about this slide, the ecological footprint. Well, in some of the introduction that I made for this module number 1, I talk substantially about the ecological footprint. That is a very important subject that we need to cover during this first chapter, and actually in Mastering Environmental Science platform, you're gonna have some exercise related to that. Okay, again, I strongly suggest to go to this page which is the page that I show you in the introductory video about module number 1, because in there you're going to find a lot of important information about the ecological footprint that is not included in your textbook. And then you're going to be able to understand better this concept. Okay, as I mentioned at that time, we are overshooting today our resources. So today we are consuming our resources thinking that we have an actual planet of this size. What you have in the background is the actual size of our planet. So almost 70% more of what we have. So more or less, the ecological footprint today is around, in average, 2.7 hectares in average all over the world. This is the slide that you are going to see later on in this lecture. Let me see if I find that one. Okay, let me see. It should be somewhere around here. This one here. Okay, you're going to see this in the questions or exercise that you're going to practice in Mastering on Environmental Science. And let me get your attention in here, because this is a very common question in your test. Always I include this in the test. Okay, so be aware of this information. The average ecological footprint today is around 2.7. Now you understand why. Okay, well, this information is back 2015, but if you go to the page that I gave you, you're going to see that the number hasn't showed too much in the last 7 years. Okay, but as you can see, the ecological footprint all over the world is different. There are some countries that have a very large ecological footprint, and we need to reverse that trend, because now you understand how that trend is going to impact the geological evolution and the geological behavior of the temperature in the planet, and what are the consequences. Okay, so that is something that I want to mention here. And let me just finish to explain probably some of the graph that you may have here. Let me check over here. This one here, this is a bar graph in which the height of this bar is telling you the percentage of ponds or lakes or smoked lakes that were covered by algae. And why that is important? Because when you have a lot of algae in ponds of waters, that creates something that is called anoxia, what I mentioned to you just a few slides ago. So the height of this bar, for those of you that are not totally related with this type of information, correspond to this number over here. So this bar graph in here corresponds to 35%, and in this one is around probably 7%. This tiny line that you see here is a measurement of the confidence that we have in this information. In other words, the uncertainty. The uncertainty in this information is around the height of this line. So from here to here we have 5%, and let's say that this is half of that interval, so around 7%. So this might be correct plus minus 7%. In this case, well, that is the control data, so the uncertainty is lower, so the confidence is larger. And actually the uncertainty is lower than 2%, which is the high of this tiny line over here. That is something that I want to comment. Okay, but you can check the details of what is the under discussion in this example in your textbook. Okay, well, just to finish this, they introduce here the scientific method. Just remember that in the scientific method we have two types of variables. Okay, the independent variable that some statisticians call these as the explanatory variables, and the response variable, which is the result. The explanatory variables are going to be the hypothesis, the one that is expected to explain the changes that we see in the response variables, okay, which are the results. Okay, that is something that I want to comment. Okay, well, I don't want to make any longer this video. We have already 36 minutes, but this is just a summary for your chapter number 1, now that we are about to finish this chapter. Okay, remember that the activities for this chapter are due the Monday after when we finish the chapter during the current week. Okay, thank you.